Assalamualaikum and very good morning. Hi everyone, my name is Madam Azrin. I will continue teaching you this subject from week 6 to week 9. For all my RPS, I believe you know me. So all my recorded video will be available at my YouTube channel, this down video, and don't forget to subscribe it. Okay, so a topic for today is we're going to do a material balance for multiple unit process. Okay, as you can see in this figure, this is a real chemical plant. Okay, real chemical plant whereby it have more than one unit equipment. So it's called a multiple unit equipment, and we're going to do a mass balance about it. Okay. Okay, you already learned about a block diagram whereby a single unit block diagram whereby you have only one block. But here, when you have a multiple unit, you will, as you can see up here, okay, it has a lot of block diagram, and each of this block diagram represent a unit of equipment. And as you can see again, the picture of a real chemical plant. Okay, last time when I heard plant, I thought it was a tree, but it's not a tree, it's a plant, or loji in Malay, or kilang in a simple word. It's a kilang. Okay, so when you have multiple unit, you need to draw a multiple block diagram because each of the unit represent by one block diagram. Okay. Okay, let us start our material balance for multiple unit process. Okay, we start with a simple one whereby we have two unit. Okay, before this you have only one unit, but now you have two unit. Okay, what you need to do, you have to really decide the arrow. Okay, the head, make sure is correct. Which one is inlet, which one is an outlet. Okay, you have to really take care about that. Okay, that is the first. When you have two unit, okay, with you can label, okay, which one is a feed, which one is a product based on the arrow, based on the head of the arrow. Okay, and then you have to decide a boundary condition. Okay, you have to decide a boundary condition. Previously you just deal with a single equipment. Maybe you don't really care about the boundary condition. You just solve the material balance straight away. But now, when you have two units, you have to decide the boundary condition. Okay, so we have here A. A is basically a boundary condition for the outer boundary condition for both of the unit. Okay, and you can also decide at each of the unit. Okay, and at a missing point. Okay, at a missing point, just example at D point, whereby a stream, the stream is split into two. Okay, from unit 1 it goes to unit 2, and before it goes to unit 2 it's split into product 1. Okay, so here also you have to do a boundary condition. Same goes when you have a mixing between two feed 1 and feed 2. So they mix here. Here also another boundary condition. Okay, slightly different from your single unit because you solve directly at that block, right? Okay, let's take a look on example 1. Okay, whereby we have two unit process. Okay, we start with simple one. First, two unit process, and later on we can go for a bigger number of block diagram. Okay, so we have this two unit process, and each of the stream having a two component, which is A and a B. Okay, A and B, and then there are three stream. Composition are not known, are labeled as 1, 2, 3. If the question already labeled for you, you can use straight away. But if the question doesn't label it for you, you have to label it first. Okay, you have to label your stream. Okay, just number it 1, 2, 3. Okay, to solve this, okay, we start with, you have to number the stream. Okay, just number it 1, 2, 3, and then you have to choose your boundary condition. Okay. So the first boundary condition could be the overall boundary condition, whereby it's cover the whole 2 units. Okay, the outer part, as you can see in this red, as you can see this red color, and then the second thing, it could be a boundary at a single unit. Okay, at each of the unit also consider a boundary condition. I believe you already learned this before. And don't forget your mixing point here. Okay, we have a mixing point here, whereby it also been considered as one boundary condition. Okay, there are there is 2 steps. Let's move on to the next step. Okay, so the next step is you have to define your unknown variable. I believe it's just about the same as you do in your single unit. You have to define your unknown variable. Okay, so define it, the mesh. Okay, we use M as a mesh and we use X as a composition. We don't know the composition of A here, so we put it as X1, and X2 is 1 minus X1. We don't use X2 because there are only 2 units, and X1 plus X2 equal to 1. So X2 is equal to 1 minus X1. So easier for us to just write straight away in this 1 minus X1 for composition of B. Okay, and then you have to rename all. Okay, you have to rename it. All the stream that you don't know the value of mesh and composition, just name it. Okay, so after you name it, all of it, we go to the next step, which is do a degree of freedom analysis. Degree of freedom analysis is based on the boundary. For example, when you have the overall boundary condition in this red color, okay, at this red color, we have to do a degree of freedom, okay, whereby the degree of freedom, which is we have 2 unknown, your M1, M3 and X3 is your unknown, so you have 2 unknown, and you also have 2 balance, which is a mesh balance and a composition balance. Okay, so you can solve straight away to get the value of M3 and X3. Okay, that is the importance of having a boundary condition. Okay, and then another boundary condition could be at unit 1. Okay, let's do the degree of freedom here, whereby it have also 2 unknown. Okay, we don't know the value of M1 and we don't know the value of X1. So 2 unknown, and again 2 balance, which is overall balance. Okay, overall balance, and also the balance for A or B. You can choose either A or B. Okay, so left out 0 degree of freedom. Okay, and another one, we at this mixing point. Okay, at this mixing point, you have 4 unknown. Okay, you have 4 unknown. You don't know M1, M2, X1, X2. Okay, and but you only can do a 2 balance, which is a mesh balance, for a mesh balance, and you can do a balance for mesh, and you can do a balance for species. Okay, and left out 2 degree of freedom. Okay, so the tip is, when you want to solve it, you have to solve the 0 degree of freedom first. Okay, because once you solve this one, you will get the value of M1 and X1. Okay, when you get this value of M1 and X1, you can solve for M2 and X2. Okay, so it's really important for you to solve a 0 degree of freedom first. Okay, So solve it. Okay, give a try. Get a pen and a calculator, give a try. Okay, so we start a mass balance on a unit 1 first. Okay, so the mass balance for unit 1, we have inlet 100 and outlet 400 plus your M1. Okay, so from this equation, this is not involve a reaction, so we just straight away this one. Okay, input equal to output because there is no reaction here, so you can straight away get the value of M1. Okay, hopefully you manage to get this value. Okay, easy, right? Okay, and another balance is a balance for A. Okay, a composition of A. So we have 0.5 times 1000 times 100, and then equal to the outlet 0.9 times 40 plus x1 time your M1, because your M1 is you already get that value, so you can straight away get the value of x1. Okay, so we solve for M1 and x1. Okay, so we continue. Okay, continue with choosing a outer boundary condition or overall boundary condition. So we do a overall mass balance. Okay, we have inlet. Okay, this one and this one should be our inlet, and this one is our outlet. So, and straight away we get the value of M3. Same goes when we have when we do a balance, A balance, overall balance on A, we manage to get the value of x3. Okay, as you can remember, here we have 0 degree of freedom. Okay, so the tips is solve for 0 degree of freedom first. Okay, and then we solve at a mixing point. Okay, at this mixing point, okay, we already know what is our M1. Okay, we do a balance here, so I just want to show you that this one and this one, you can convert it into this one. If you get confused by this symbol, okay, you can convert it into this one. It's just about the same. Okay, it's just exactly the same. So you have M1, okay, M1 plus 30 equal to M2, and you can straight away get the value of M2. Okay, again, you do a balance of A at this boundary condition, at this mixing point, you can get the value of x2. Okay, and hopefully you get this simple example. If you have any question, you can ask me later on.